Hello students, you're welcome back to Waidsum University. This is chapter 6, part 2. This topic for this chapter is the TCP IP layers. Okay, so without much ado, let's begin. Let's begin. Now, first of all, let's quickly take a look at the model, the TCP IP model. You know, we have the OSI model. We studied that in chapter 2 through chapter 4. Okay, we looked at the OSI model. Now today we're looking at the TCP IP model. And you remember last class in chapter 5 we introduced the TCP IP. We mentioned that that the TCP is transmission control protocol or Internet protocol. So it has 4 different layers, or 4 different. The model has 4 different layers. So the first from the bottom part is the network interface. Okay, we're going to compare this with the OSI model. We have what we call the network interface layer. We have, okay, let's take our regular color. Okay, we can always interchange. We have what we call the OSI network interface layer. We have this one. And then we have what we call the internet layer. And then we have what we call the transport layer. And then we have the application layer. Now, for the network interface layer, it actually tells us how the host connects to the network. So this is principally talking about the host, how they connect to the network. We have to be fast because this class is 70 pages. So this slide is 70 pages, so we have to really move fast. Okay, so you pardon us when we characteristically increase the speed. Okay, so the next layer is the internet layer. The internet layer tells or defines the protocols used for addressing and routing the data packets. Okay, then the third layer, which is the transport layer, it's also the transport layer for the OSI. Remember this network interface layer, it's called both the physical layer, which is the OSI layer. When we are describing the OSI layer, we talk about the first one, the physical layer, then the data link layer. So both the physical layer and the data link layer signifies this network layer in this regard. Then in this one, in the OSI layer, we call the network layer is what we call the internet layer here. We're going to compare and contrast both of them. Then the transport layer is also the transport layer in the other application, in the OSI application or OSI model. But for this TCP IP model, the transport layer, it's also the transport layer in the previous case, and it tells us or defines the types of connection that is established between hosts and how the acknowledgements are set from host to host, okay, on the network. Then we have the last one, the application layer. This one in the OSI layer includes the section layer, includes the presentation layer, and the application layer. So 3 layers will represent this application layer in the OSI model. In the OSI model, we call this section layer, which is number 5, then a presentation layer, which is number 6, and application layer, which is number 7. So all 3 of them is what is model to be only application for the TCP IP layers. Okay, these TCP IP layers, it defines these application layers in TCP IP. It defines the application that is used to process the request, what ports and sockets are used. Okay, so like the ARP, the address resolution protocol, and so on and so forth. So the application layer is applicable. So there are 4 layers of the TCP IP model, and we've itemized them with the internet interface layer, the network interface layer, the internet layer, the transport layer, and the application layer. Okay, now let's move on quickly because we have a long way to go. Okay, so still on this one, we said the TCP IP protocol. First of all, we already established in the first section 1 of this chapter that it was developed or established in 1978. We already established this in the first section. Okay, prior to the formation of the OSI model, just before the OSI model was introduced, so this TCP IP model was formed. This we have discussed previously in chapter 2 and chapter 4 previously. Okay, so this TCP IP model has 4 layers as we've described. Okay, now let's move on quickly. Now let's benchmark the OSI model. This is the OSI model. It has several layers. The OSI model has several layers, while the TCP IP model has 4 layers. TCP IP model has 4 layers. Now, in the OSI model, we have the physical layer and we have the data link layer. We have the physical layer, we have the data link layer. Are you with me? Okay, in the OSI model, we have the physical layer and we have the data link layer. Then, for TCP/IP model, it's just called the network interface layer. Okay, good example of protocol suites that are used with the various layers are the Ethernet protocol, the ATM, asynchronous transfer module. Then we have the token ring, we have the frame relay. These are the different applications that are used, protocol suites that are used in this layer. Okay, so for the network interface layer, when you come to TCP/IP, it comprises of two layers in the OSI model. In the OSI model is the physical layer and also the data link layer. Okay, two of this is compressed to give this one the network interface layer. Now let's take a look at the next one. The third one for the OSI model is network, and it's called internet layer for the TCP/IP model. And the application you can find, the protocol suites that are used here are the IP, that's Internet Protocol, the ICM, Internet Control Message Protocol. We have address resolution protocols. These are the protocols that are used with this layer. It's called the network layer for the OSI model, which is level 3, and it is level 2 for the TCP/IP model. Okay, then the fourth one for OSI model is the transport layer. It's the third one for it is called the third layer for the TCP/IP model. And a good example of the protocol that is used, transfer control protocol, and user datagram protocol, UDP. So these are the protocols that are used in transport layer. These are for communication purposes. These protocols are for communication purposes. The UDP is for established collectionless communication, okay, between two hosts on a network, while the TCP is for establishing connection before communication. Is that okay? So then the last layer for the TCP/IP is the application layer, but it characterizes or comprises of 3 different layers for the OSI model. We have the session layer, the presentation layer, and the application layer. So, but all these 3 is compressed to become application layer for this one. So we have one, the telnet, which is part of a protocol that is used in this is protocol suite that is used in the application level. We have the file transfer protocol, the FTP. We have the simple mail transfer protocol, which is used at this layer, application layer. We have the domain name server. We have the simple name message protocol. Okay, so all these are used in the application layers. Okay, is that okay? So let's move on quickly because of time. Now let's take a look at the second table. This table is talking about the ports that are assigned to the different ports that are assigned in these applications. First of all, we look at the port numbers that are assigned. We have 3 categories of this port. We have the one we call the well-known ports, which are from 1 to 1023. They are called the well-known ports. Okay. Then we have what from 1024 to 49,151. They are called the register ports. Okay, when you do subnetting on this one, we'll study in the next chapter. Oh, I think this chapter as well. Yeah, this chapter, one of the sections in this chapter. Then we have what we call the private ports. They are from the range of 49,152 to 65,535. These are called the private ports. Is that okay? So private port, get this assignment, okay? The different is assigned to the network. Now let's take a look at the application layers of the TCP IP stack. It's responsible for making sure that connection is made. The application layer, okay, is the one that is responsible to ensure that connection is made to any appropriate network port. So you remember the application layer links the protocol to the hardware. Okay, so it is responsible for ensuring that there is a connection between the protocol and the network ports. These ports are reserved by a body called the ICANN. ICANN means Internet Corporations for Assigned Names and Numbers. Internet Corporation for Assigned Names and Numbers. So these ports, every computer is assigned a unique port, right? So from the router or from the networking device. Now let's take a look at another table 6.3, common applications and their port numbers. Now let's take a look at very common ones. We measure huge numbers for port applications. We say the private ports ranges from 49,152 to 65,535. So you can see these are huge numbers. These are not just small numbers. So, but let's take a look at the commonly used ones, okay, or frequently used ports, and the kind of applications that you find there and what they mean, what this application mean, the description. First of all, when you say port 23, it's used for Telnet. Telnet is in the application layer, right? Telnet is one of the protocols in the application layer, okay, and it's it's used for virtual terminal connection. That's what we use Telnet for. That's virtual, like the connectionless, like the one you don't see physically. Virtual terminal connection. That's what we use Telnet for. Then when you hear port 20, port 21, they are for what? File transfer protocol. Okay, the file transfer protocol is part of the application layer. It's part of the application layer. So, and then the file transfer protocol is what this one, it helps to transfer from the host, from the client host to the server host. Okay, that's what it does. It helps to transfer messages from the host client or client host to the server host. Now, when you hear port 25, it's usually applied for SM, Simple Mail Transfer Protocol, SMTP. So it's simply for sending mails. And then when you hear port 53, it's very common with DNS, which is called the domain name server. Not okay, domain name servers. Okay, so when you hear port 65, 67, 68, it's used for the dynamic host control protocol, which is DHCP. And this dynamic host control protocol includes the BoostP client and BoostP server. Then when you hear port 69, it's usually used for TFTP. That's Trivial File Transfer Protocol. Okay. Then when you hear port 80, you hear HTTP, Hypertext Transfer Protocol. So these ports are all used in the application layer. Okay, they are assigned in applications. Common ports that are usually assigned in the application layer to carry out work. Now let's begin to describe the next one. We've talked about the application layer. We've measured the protocols that are used and the ports assigned to these protocols and what they do. So we've signified that. So since here we measured the ports, we measured the different ports, the well-known port, the registered ports, and the private ports. And then here we mentioned the ports as they've been assigned, port numbers as they've been assigned to different applications or protocols on the network in the application layer. And then here we at least we've studied the brief. We have brief knowledge of the application layer. Now let's move to the next one, which is we take the transport layer. Okay, as you're going down. So from application we come down to transport. Now the transport layer protocol, in your TCP IP layers, they are very important in establishing a network connections. So one of their big tasks is to establish a connection so that you can communicate, so that the two hosts can communicate, or two computers on the network can communicate. So not only to establish a network connection, they also use the transport layer, also used for managing the delivery of data. Managing the delivery of data between the source and the destination host. Excuse me. Sorry. Okay. Okay. So we say they're used for establishing the network connection. That's the transport layer protocols. And we say not only for establishing connections, they're used for managing the delivery of data, of course, because that's why they're called transport. The word transport should tell you what that signifies for establishing the delivery of data from the source and to destination host, and also not only that, for terminating the data connections as well. Okay, whenever the job is done, we've delivered them, we end it. Okay, for terminating. So the transport layer does these three unique jobs: one, establish connection; two, manage the delivery of data from source and to destination; and then the third one for terminating the data connection when it's done. Then let's talk about the next one. They say there are two transport protocols that are commonly used in this level. The first one is called the TCP. The second one is called the UDP. Now, one requires connection, the other one is connectionless. The TCP requires a connection between two hosts, while the UDP is connectionless. Okay, like video streaming, audio file sending. All those ones, they don't need the connection to be established between hosts. Okay, now let's move on quickly. The TCP, the first one, is called the Transport Control Protocol. The TCP itself is called the Transport Control Protocol and is a connection-oriented protocol. So this one requires connection, like as I have earlier mentioned. So it's a connection-oriented protocol. A connection-oriented protocol has to establish connection between hosts, right? Manage the data and terminate it at the end of the day. So it carry out these jobs that we have itemized earlier on. Carry out all the three functionality of the transport layer. These three functionality of the transport layer are being carried out with the TCP protocol. Okay, remember we say transport protocol. The transport layer is made up of two protocols, the TCP protocol and the UDP protocol. The TCP is called the Transport Control Protocol. The UDP is User Datagram Protocol. Okay, the TCP is for establishing connection between two hosts in a network, while the UDP is a connectionless mode, okay, of communication. Now let's still talk about the TCP. The TCP protocol establishes a set of rules or guidelines for establishing connection. So protocols are actually a set of rules, right? We know this. So the TCP, what they do is to establish the set of rules or guidelines for establishing connection. TCP also verifies the delivery of the data packet, whether it went through the network, and it includes the support for error checking, whether there was an error, whether it got to where it's supposed to go, whether it's lost, and also it helps in the recovery of lost data. Okay, you can see the TCP also help in the recovery of the lost data in case anything happened. There was error in the way, some packets were lost. So it helps us to recover some of the lost data. So you can see the functionality of the TCP under the transport layer, right? The TCP there specify the procedure for terminating also. Okay, you go to terminate like this, you go to terminate this data packet in this manner. So it will specify the procedures to use in order to terminate the. Yeah, let's move on quickly. Now, this is an example of what we're talking about. You can see a host A communicates with host B responds, they acknowledge the communication. So, okay, so it's a host A will synchronize. Synchronize means get a connection with host B will send an acknowledgement. Oh, okay, I've received your synchronization. Okay, I've received your this thing. So there is always a unique sequence of three data packets exchanged at the beginning of a TCP connection. We're going to describe these three sequence level, these three data packet exchange at the beginning of every TCP connection between two hosts. So once we have two hosts, host A in this manner and host B, there is always a three-way connection that will be established. We're going to describe them, okay, quickly. The connection between the two hosts is what we're going to describe as follows. And this is a virtual connection. Hope you know this. It's not like wire to wire. It's a virtual connection. It's not like the physical connection. Okay, it's just like Waidsum University. Okay, it's a virtual connection made over the internet. Is that okay? That's what it is. Now, the first three packets always exchange between two hosts whenever you are establishing a TCP connection as follows. First, the first one is the synchronizing packet. So host A sends a synchronization to host B. So synchronizing the packet, data packet. Okay, say okay. That's the first stage. Synchronization of the data packet with host B. Host A is the one that will initiate that and send that to host B. You say, can you see me? Okay, this data. Can you see this data packet? I want to communicate with you. Then host B will now respond. We send the synchronization plus acknowledgement. Say, oh, I have seen your synchronization. I have seen your synchronism, and I have also seen your, this is my acknowledgement. I see your synchronism. This is my acknowledgement that I have seen your packet, your data packet. Okay, that's the second phase of this connection establishing protocols or methodology of establishing connection in TCP. The third one is, okay, host A will say, okay, you've seen my acknowledgement. Okay, I've also received an acknowledgement that you have. Here is my acknowledgement that I have received your acknowledgement. So that's the third stage. Yes, the host A will now signal B. Okay, here's my acknowledgement that I have received your acknowledgement. That's the third phase. Now let's move on quickly. Here is the description below. We call them the TCP handshake. Okay, maybe I remove this so you can see. It's called the TCP handshake. We call the 3-packet initial TCP handshake. Now let's take a look at them. Packet 1, this packet 1. Host A is the one who initiate the discussion. Host A is the one who initiate the discussion. Say, send a synchronization to host B. Host B will now respond by sending an acknowledgement. You see, host B is going this way now. He send it, say, okay, I've received your synchronism or your synchronization, and here is my acknowledgement that I have received your synchronization in sequence. So host B will now communicate with host A. Then host A in the third packet that host A will send will be, okay, here's my own acknowledgement that I have received your own acknowledgement. These are the 3 stages of the 3-packet initial TCP handshake. Once this is established, before they will begin to send data to each other. Now let's move on quickly. Okay, we say following example of TCP packet transmission capture using a protocol analyzer. Now let's use a protocol analyzer. Here is the client. Host A is the client. Host B is the FTP file server. That's the file transfer protocol server. Okay, the file transfer protocol server. So host A will first of all send synchronization. Can you see me? Host B will send both the synchronization and acknowledgement. Yes, I can see you. Here's my packet 2. Yes, I can see you. Then host A will also say an acknowledgement. Okay, I've received your acknowledgement. So that's what you see here. And then the data is set up as shown. Host A, which is declared, is establishing a FTP connection with host B. The captured data is shown and is provided on the CD-ROM in the capture folder. Portion of the captured data will be shown now. Now let's take a look at this. What you see. This is the handshake, TCP handshake. What do you see? You can see that packet 1, which has an ID number, is the synchronizing or synchronization packet. The synchronizing packet is first of all sent to host B. This packet is sent from the host A on the computer, host A on the computer on the network to the file server, the FTP file server, to establish a connection. In exchange, the host B, the file server, will send an acknowledgement with the synchronization. Say, okay, I've received you. And then, now let's describe what happened, the result of what is happening. Now, if you take a look at this, you see that they are using TCP as in the transport control protocol. So the first thing is, you see here the SP, which is the source port. Okay, this is the source port. It shows here that the source port is 1054. Okay, which is the register port. Okay, falls under the register port. And then this is destination port 21, which falls under the well-known ports. So you see it's sending a synchronization, and this is the sequence number. So at this point, acknowledgement is 0. The length of the data is 0. When we say length of data packet is 0, what it means is that there is no data in the packet. There is no data in the packet. It's just a packet of acknowledgement or of synchronization. So there's no data in the packet. Then the window size is 16,384. Okay? The window size is 16,384. So that's what we see. Look at them. This one, what it means is that the TCP, the first one, packet A, is sending a synchronization packet to the client server, which is host B. Okay? Then another thing you see here, they are trying to establish a TCP, meaning a connection between two hosts. Then the next thing you see is that you see the source port. That the message is coming from this computer. The source port is 1054, which is a register port. Then the next one is the destination port, which is the well-known port. Is that okay? Is that okay? So you can see these are what are explained in this data packet. So we go quickly. Here is the sequence of what is to be sent. Okay. Then here is acknowledgement is 0, meaning the host A that is sending something is not, for the first time, is not sending an acknowledgement yet. Then here is the length of the data packet 0, meaning that there is no data in the packet. Then here is the window size. Okay, so that's that for the first case. Now let's take a look at the packet 2, which is this one. Packet 2 is now what is sent from host B to host A, which is both the synchronization packet and an acknowledgement. Synchronization packet and an acknowledgement. This is coming from the FTP, the File Transfer Protocol server. So it's coming from the File Transfer Protocol server. So the sequence number is given. Look at the sequence number from here. The sequence number, or you can also see it from here. The sequence number is given, and is the start of a new sequence. Is the start of a new sequence number for the data packet transfer from B. Now the source port is what? If you take a look at it, this time around the source port is 21. Yeah, the source port is 21 because you know why? The destination in packet 1, the FTP file transfer server is now the source that is now sending an acknowledgement to host A. So the destination is not the one that was the original source. So the destination port is now 1054. Okay, let's be fair because this is a lot. I have a lot of work to do. Then you can see the sequence. Then you can see the source port, the destination port. Then you see the acknowledgement. Now, in this case, it is very significant for us to know that the acknowledgement here, the acknowledgement we receive from here is 1 plus the sequence that was sent in the first one. Just add 1 to the sequence of host A, you get the acknowledgement, or the value of the acknowledgement from B to A, from host B to A. So you can see this ended in 768. If you add 1, it becomes 769. That's how we got this acknowledgement. So this is what you see here, both of them be compared. So adding 1 to a sequence of host packet 1, you get the acknowledgement of packet 2. Okay? So that's it. That's what we get here. So now let's go to the third case. Third case is that the host A will now send acknowledgement to B that, oh, I have received, you see the source port is the original source port, this first one, host A. So it's the source port here. And the destination port is 21. The sequence number is this one. And then the acknowledgement is 1 plus the previous sequence number. And then you get the window size. This time around, it has a window size, right? And also even this packet 2 has a window size. So you see the window size is this. The length is 0, showing that there's no data in the packet. Okay, so that's that. Now let's move on quickly. To get the acknowledgement here is to add 1 to the previous sequence. I've explained that. Now let's move on quickly. So this is what is happening. You see, terminating the TCP section. If you want to terminate, host B will now send a finished sequence acknowledgement to host A. Host A will send sequence acknowledge. So host B will send I have finished sequence acknowledgement to A. A will say, okay, sequence acknowledge, I have received that. Then host A will now say, okay, finish sequence acknowledge to B. B will say, I have acknowledged. Then they cannot terminate. Then they both cannot terminate. First of all, it was B that said finish sequence acknowledgement to A. A will acknowledge it. Then A will send the same thing to B. Say, okay, finish sequence acknowledgement. B will say respond by saying yes, sequence acknowledge. Then they cannot terminate the section. Whenever they need it again, it will start automatically. Okay, so I think we've given a similar example like this. I don't have to repeat this part. Let's move on quickly. I've explained a section like this. Let's move on. Okay. Now let's go to what we call the UDP. UDP, like we said, the meaning is user datagram protocol and is a connectionless. Meaning no connection needs to be established between two hosts on a network. So it is a connectionless protocol. This means that the UDP packets are transported over the internet without a connection being established between any two hosts. No need to send a sequence or synchronization to another host, and no need for acknowledgement. Okay, so they don't need this, and they don't need between the source and the destination. Okay, UDP is useful in applications such as video conferencing. Yeah, because when you're doing video conferences, you don't need to establish a connection between two hosts, or you're sending audio feeds. You don't need the acknowledgement of data packet. They are not needed. They are not necessary. You don't need it. So in that case, we use what we call the UDP, User Datagram Protocol. Is that okay? It's a connectionless protocol. Okay, so a UDP packet transfer. Let's take a look at this. Packet is similar to, in this case, we are using a UDP instead of TCP, similar to whatever we have described. So you can see the packet 136 here. Look at the number 000136. Packet 136 is the start of the UDP packet transfer of an internet audio feed. Now, a TCP connection to the internet was first made, and then the music feed was started. So you can now send the music, and then at that time, the UDP connectionless packet started. Okay, let's take a look at it. Then the ID 138, 139, 140 will receive whatever that was being sent by ID 136. Is that okay? And you can see the length is 700. The length of the data is 789. 789. That's what they receive. That's what was sent. That's what they receive. Is that okay? Let's move on quickly. Now let's go to another layer called the internet layer. The internet layer. So we finished the transport layer. We're coming down now again to the internet layer. After the internet layer, we go to the network interface layer. Now, the internet layer, in a TCP IP model, on the TCP IP, which is the internet layer defines the protocols used for addressing and routing the data packet. So the particular protocols that are used for addressing and routing data packet, these are called the internet layer of the TCP IP model. Now, the protocols that are part of the TCP IP internet layer include what? The IP, that means internet protocol, the ARP, which is the address resolution protocol, the ICMP, which is the internet control mail protocol, the IGMP, internet group mail protocol, internet control message protocol, and the IG, internet group message protocol. So these are the protocols that are used in this layer. Actually, this layer links the protocol to the hardware. Okay, let's move on quickly. Now the IP protocol, that's the internet protocol. The IP, or what you simply call the internet protocol, defines the addressing used for identifying the source and destination addresses. Something that you use to identify your source and destination. Source and destination addresses. Okay? The protocol that is used to identify the source and destination of data packets that is being delivered over the network. Is what we call the internet protocol. The protocol that is used to determine or to deliver or to identify the source, not deliver, to identify the source and destination of data packet that is being delivered in the network. The IP address, remember, we call it the logical address that consists of a network and a host address. So this IP address consists of two things: the network address and what we call the host address. Okay, the network address and what we call the host address. The network address is used to route data on the network, right? The network address we use to route data on the network. The host address helps us to identify or to address the local assigned host, to identify which computer this thing is being assigned to, or the networking device that can carry it to the final host or the final destination. So that's what that is. Okay, now let's move on quickly. Now, what is the ARP, the Address Resolution Protocol? Address Resolution Protocol is simply used to resolve an IP address to a hardware address for the final delivery of the data packet to the destination. So you have an IP address, you need something, a kind of protocol that can link your IP address from the internet to the hardware machine, like your computer, okay? To link it with the hardware, to link a specific protocol that can link the IP address with the hardware address for final delivery of data packet to the destination. That protocol is called the ARP, which is the Address Resolution Protocol. Address Resolution Protocol. Now, the ARP issues a query. How it works is that the Address Resolution Protocol will first of all issue a query in a network called the ARP request, meaning send a request like a query, asking which network interface has the IP address. So the ARP will issue a query asking which of these network interface has this IP address. Then the host assigned to the IP address will reply, yeah, I'm the guy, I'm the one. We reply with the ARP reply that contains the hardware address that is showing that is the one, is the destination. Otherwise, then it will go to the networking device that can take it to the final destination, if this is not the case. Is that okay? Now let's move on quickly. Now here is the practical scenario. You see that you see the figure. As you can see, we have the part that is highlighted with blue. You can see this part, this place, all the horizontal place here that is highlighted with blue. You can see the IP address. You can see packet size. You can see the broadcast, meaning it will be broadcasted to all computers on the network. You can see the MAC address from the source where it's coming from. See the ARP is saying that the address resolution protocol is in place to link the IP address to the hardware address. Okay, and here is a query, meaning a query has been sent, and this query is asking which device has this 10.10.10.1. This 10.10.10.1 is the internet, is the IP address. So a query is sent by this address resolution protocol, saying asking that which hardware address has this IP address, which hardware has this IP address. Okay, then there will be a reply through this gateway. You see for size the MAC address. In this case, this MAC address is a destination address. See, other destination. This is the MAC address. This is the destination where the packet is going. Okay, this is the destination where the packet is going. So it will reply by saying, oh, I'm the guy. The source address is here. You say, okay, I'm the guy you're supposed to deliver to. So it will reply. This arrow means reply. This Q means query. Query was sent, and it will reply, I'm the guy. That's the meaning of this handshake. They will shake hand with the MAC address. Okay, so that's how it's being identified. Is that okay? So let's move on quickly. Okay, I think I have explained all this concept already. Yeah, let's move here. Now the next one is called the ICMP protocol. ICMP protocol. The ICMP is the Internet Control Message Protocol, and is used to, still on this layer, still on the internet layer. We say is the Internet Control Message Protocol, and is used to control the flow of data in the network. The flow. So control the flow of data in the network. And not only that, also for reporting errors, if there is any. So, oh, there's error here. And also for performing diagnostics, like securing it, saving, removing the error, and recovering the data. So a networking device such as the router sends an ICMP source query packet to the host that requests a slowdown in the data transfer. So the router has this protocol, can send this type of protocol, okay, to the data that has the host that requests the slowdown in the data transfer. Now, very important, this is very used for troubleshooting It's like a troubleshooting tool that is used in solving any problem arising from this layer. Now we have what we call the IGMP protocol. IGMP protocol is simply the Internet Group Message Protocol. Internet Group Message Protocol. IGMP is used when one host needs to send data to many destinations. One host, like one computer, needs to send data to many destinations. This is simply multicasting. This is what? Multicasting. That's when we use the IGMP protocol. When one host on the router, on the network, on the router is sending data to many destinations. Okay, so we use this IGMP protocol. The address used to send the multicast data packet are called the multicast addresses. Okay, these are reserved addresses that are not assigned to the host on the network. These addresses are reserved, and they are specifically used to send multicast messages to the destinations. Now, an example of application that uses IGMP packets is when a router uses multicasting to share routing tables. This is a very good application of it. Router using multicasting technique to share routing table. This is when an IGMP protocol is put in motion. Is that okay? Okay, now still on IGMP, another application to use IGMP or that normally use the IGMP packet is when a host wants to stream data to multiple hosts. When a host wants to stream data to multiple hosts, then they use the IGMP. Okay, like video conferencing. So streaming simply means that the data are sent without waiting for any acknowledgement of the data packets. Whether they are delivered or they are not delivered is not our business. We don't wait for acknowledgement. That's streaming. So streaming, we don't wait for acknowledgement. We just send. Okay? In fact, the IGMP protocol, the source doesn't care whether the destination received the data packet or not. Doesn't care. It's none of his business. Just keep sending. So that's when we use IGMP. When, for example, the protocol that is put in motion, when you are using Zoom now to give group lecture, one of the protocols is called the IGMP. Internet Group Message Protocol will be sent. Will be used to send messages to multiple viewers on that will be the destination. Is that okay? And let's move on. The next one is the network. The last one is the network interface layer. Now the network interface layer for the TCP/IP model. Remember in the OSI model, this is in two stages: the physical layer and the data link layer. But for the TCP/IP model, it's just called the network interface layer. The network interface layer of the TCP/IP model defines how the host connects to the network. That's it. Just from the name, how the host connects to the network. That's why it's related to the physical and the data link layer of the OSI model. Okay, that's how we say it has almost similar functionality with the physical layer and the data link layer of the OSI model. So the network layer is just to define how the host connects to the network. Now the host could be a computer connected to an Ethernet or a token ring network or a router connected to frame relay wide area network. Could be any of these. Is that okay? TCP/IP is not dependent on the specific networking technology, so TCP/IP can be adapted to run on newer networking technologies such as ATM. On this network layer, we use the ATM, which is called the asynchronous transfer mode. ATM asynchronous transfer mode. Okay, so this is one of the protocol that is used in this network layer, ATM. Okay, so that's the end of this section. These are the terminology that we have used. Thank you very much for joining us once again. Thank you for joining Waidsum University.